20,000 every second. That is the velocity of global plastic bottle consumption. By the time this minute is over, we will have purchased 1 million. This volume compounds quickly. By 2021, the world was going through over 583 billion individual bottles a year. The vessel of choice for nearly all of these liquids is polyethylene terephthalate, or PET. It is highly valued for being lightweight, completely shatter-resistant, and visually indistinguishable from glass. The soft drink industry consumes roughly 470 billion of these PET units annually, but the single largest driver of that demand is bottled water, accounting for 185 billion units on its own. Producing packaging on this scale requires an industrial apparatus fine-tuned over decades to manufacture, fill, and distribute single-use vessels with absolute precision. The supply chain for these bottles begins far from any bottling plant. The foundation of every PET container is extracted fossil fuels. Manufacturing the PET required solely to satisfy the United States market demands over 17 million barrels of crude oil every year. Extracting that crude oil and natural gas and refining it into usable plastic resins also requires immense volumes of water, what researchers classify as the blue and gray water footprints of production. This animation illustrates the ratio. It takes an estimated 1.4 gallons of fresh water just to process the plastic required for a single empty 500 milliliter bottle. The modern beverage system relies on an intensely streamlined manufacturing process that continually draws down finite fossil fuels and local water tables to create a disposable product. Once refined, the raw petrochemicals are extruded into millions of tiny, uniform PET resin pellets. These pellets are heated and molded into small, dense tubes called preforms. In specialized factories, machines heat these preforms until they glow, injecting air to expand them perfectly into molds in a fraction of a second. From there, the empty vessels move on to mechanized, high-speed filling lines. Advanced rotary fillers can sanitize, fill, and cap tens of thousands of bottles every hour, packaging millions of units each day with virtually zero human intervention. Within seconds, raw hydrocarbons are transformed into standardized, sterile consumer products, feeding a continuous global supply artery. Reaching the consumer often involves a highly fragmented international journey. Brands like Fiji Waters source their PET resin from chemical plants in China, ship the material to the South Pacific for molding and filling, and then export the finished product to markets in the West. Transporting this virtual water thousands of miles across the ocean requires significant fuel consumption, adding a massive secondary layer of carbon emissions to the supply chain. The final destination is a retail shelf, engineered to offer endless repetition and instant access. The consumer buys the bottle, drinks the water, and throws the container away. The average duration of this interaction is about 15 minutes. The material itself is engineered to resist natural degradation for up to 1,000 years. A global logistics network is deployed to extract, refine, mold, and ship a highly durable product across oceans, purely to facilitate a momentary, disposable convenience. At the end of that 15-minute lifespan, the linear system breaks down. In the United States, only 23% of these bottles are collected for recycling. The rest accumulate in massive waste streams. Millions of tons of this mismanaged waste escape landfills entirely. Today, plastic bottles and their caps account for nearly 12% of all recorded marine litter worldwide. This leakage is highly concentrated. Researchers estimate 90% of plastic flowing from land into oceans travels through just 10 major global river systems. The damage is severe in inland waters as well. Lake Michigan alone receives the equivalent of 100 Olympic-sized swimming pools full of discarded plastic bottles every single year. In aquatic environments, these macroplastics do not biodegrade. They fragment under UV light and wave action into micro and nanoplastics, which are then consumed by fish and bioaccumulate up the food chain. The economic model that optimized the creation of the PET bottle failed to plan for its disposal, converting a highly engineered product into a permanent geological pollutant. Recovering this material is economically difficult. Processing collected bottles into food-grade recycled PET requires intense decontamination, a step that frequently makes recycled plastic more expensive than cheap virgin resin. This flowchart visualizes the overall inefficiency of the current pipeline. Out of every 100 bottles that enter the global system, The recycling process aggressively shrinks the yield until only 7 re-enter the loop as new bottles. Reversing this trend requires structural interventions, starting with deposit return schemes. Jurisdictions using a return-to-retail model, where consumers pay a small deposit refunded upon returning the container to these automated machines, consistently achieve collection rates up to 89%. To cover the remaining costs, governments are implementing extended producer responsibility laws. These policies shift the financial burden of waste management back to the beverage brands, forcing them to design for recyclability. On the technological front, facilities are deploying enzymatic depolymerization. This process uses enzymes in water to detach the complex, rigid polymer chains of plastic waste, dissolving them back into their original virgin-like base molecules. Bringing the global water footprint and plastic crisis under control requires dismantling the linear supply chain. True sustainability relies on legally mandating closed-loop systems, ensuring that every vessel engineered to last a millennium is aggressively reclaimed, broken down, and reused.